A confirmation about the audio, please, guys. Apologies for a slight delay. If the audio is clear and available, kindly confirm. Okay, perfect. Thank you. So again, let me ask you any issues that you have faced till now in today's session. Any of the issues, any of the areas which are giving some amount of anxiety? No? Perfect. So now, what we will do is we'll talk about the ocean currents in each of the separate oceans. Let me also tell you before that the type of questions that can be asked from here. So, in general, when you take a look at the questions which have been framed from here, and this is one of the area from where UPSC, mind you, has repeated the questions. There are very few areas in geography, world geography, or in general, where UPSC repeats the same question. So UPSC, for example, in geomorphology, repeats the ring of fire, Pacific ring of fire always. Global distribution of earthquakes and volcanoes, they are repeated. In climatology, tropical cyclone, its formation and naming, that is repeated. In oceanography, the ocean currents, its formation, and the factors influencing the ocean current, that is repeated multiple times, right? So, for example, even this year, you had the question that is, what are the ocean currents? What are the various different, or it was asked last year, that what are the various different forces which influence the ocean current? So, like that, you have those kinds of questions repeated. Now, also, you have certain set of questions, certain type of questions which will have a form whereby, for example, it can be asked that discuss or what are the ocean currents, discuss the factors influencing the ocean currents, taking the Atlantic Ocean as an example. So in that kind of questions, I will repeat the question, listen to it carefully. What are ocean currents? Discuss about the factors influencing the ocean currents along with the examples of the of the Atlantic Ocean. So in that case, while you are going to address the initial portion of it, that what do you mean by ocean currents, etc., in the later portion of the answer, you have to talk about the factors such as Coriolis force, shape of the coastline, and thereby, with the help of it, explain the oceanic currents in the Atlantic Ocean. You have to observe that mechanism and you have to explain that mechanism. But then, please don't get anxious about it, that how are we going to recall or retain all these various different ocean currents and what is the mechanism involved. For your prelims, what is going to be relevant is you should be aware that, for example, Beniguela current is a current present in which of the ocean? Atlantic, Pacific, Indian, right? And for example, Canary current, is it a cold current or a warm current? So that again is something that you should be aware of, that whether an oceanic current is cold or warm, whether a particular oceanic current is present in which ocean, that is something which you should be aware of. And when you revise this portion repeatedly, this will automatically come to your mind. This is no rocket science involved, that for that you need to have a certain level of mental proficiency, etc. Very simple thing. And all the ocean currents are driven by the same principle. Same principle is involved. What is the principle? Heating by solar insolation. So heating by solar insolation means water will expand, and when you have water which is in expanded state, it will tend to have a flow in a particular direction, in a certain path, in a certain area, it will have that flow. Now that is aided by the wind and the Coriolis force. So that is what influences the entire movement. So whatever we will observe in the Atlantic, something very similar is observed even in the Pacific, and very similar is also observed in the Indian Ocean as well. Only the northern Indian Ocean is variable, but that is because of the seasonal reversal of wind, something that we have accustomed ourselves well when we were studying about the Indian monsoon. Okay. Now, here, first of all, the details of it, the written portion of all these ocean currents are going to be provided to you, are already provided to you in the form of the additional reading materials. So don't worry about making copious notes. As of now, I want you to simply observe this, understand the mechanism involved, how is it that it gets generated, okay, and try to form a trend, a kind of a pattern associated. Okay, so rather than jotting it down, noting it down mindlessly, pay attention to the screen. Once you understand Atlantic, similar template will be followed in other oceans also. Okay, with that, let us proceed with the portion of Atlantic Ocean. Atlantic Ocean. First, we will cover the portion of Northern Atlantic. Then we will apply the same logic and same principles to understand the Southern Atlantic also. Okay, so almost a similar principle will be involved. I have a Benjita. No, from here you can have questions in the mains examination also. Right, frequently questions are asked from here in the mains examination. Um, Gaurav, in 2 to 3 page, I'm unable to write 250 words. It took 4 pages. So take a look at it, that what is the margin that you are providing in between the various sentences, the gap that you are providing in between the various sentences. Take a look at that. Try to reduce that. And with more practice, automatically, trust me with this, when you write more, your ability to accommodate more words, your ability to concise your thoughts and everything together, everything improves. So it will improve. Okay, generally 3 pages are 3.5 to 3 pages are more than sufficient. Now here, just a moment. So now we talk about the portion of, or the region of, Atlantic Ocean. Now observe here, first of all, first things first, what happens around the region of equator? There is significant and substantial amount of heating, and due to that substantial amount of heating, there is an expansion in water. Water in itself tends to expand ever so slightly, and as it expands, it will gain a kind of a height advantage. It will have a tendency to flow, but to flow in which direction? That direction is provided by the winds. So first thing is basically expansion of water due to insulation, of water due to insulation. And then after that, winds provide the pathway for movement. Okay, now around the region of equator, what happens? You have the presence of the trade winds. You do have the presence of trade wind systems, isn't it? Now, these trade wind systems, they will carry out all the bulged up water, the expanded water, from the east to west direction. That will be the first movement. From the east to west direction, that will be the movement of water, right? So thereby, because we are considering only the northern Atlantic as of now, thereby you will have the generation of the north equatorial current. Almost similarly, you have the south equatorial current also. Now that means, and remember the slide here, the slide that we had talked about earlier, if you recall this, observe here, these trade winds, they will carry away the warmer waters from the east to west direction. And observe here, there is a general accumulation of that water, a general accumulation. So some water will be diverted due to the shape of the coastline in north and south direction. But that surplus water which is prevalent, some of that surplus water will start flowing back. Some of that surplus water will start flowing back. Why will it flow back only in that direction? Here again, the same principle that we had used while we were talking about Madden-Julian oscillations. Planet Earth is continuously rotating at a very fast speed from a west to east direction. Continuously. Planet Earth is moving in a west to east direction. So that provides that momentum, that provides the level of inertia for the accumulated water to move from west to east. That is why here some accumulated water will move west to east. This is present in all the oceans. And this is what is also referred to as the counter equatorial current, because it is moving in an opposite direction as compared to the north and the south equatorial current. It is moving in opposite direction. But why is it moving in opposite direction? Because you have accumulated water on one end, and then the planet is continuously rotating from a direction of west to east. So that provides an added inertia for the water to move, and that is when the water indicates a movement from west to east direction, right? Now the water initiates that motion, and followed by that you will also have a slight movement of wind, by the way, around the region of equator in the same manner. And that is also what is referred to as sometimes equatorial westerlies, which is much more prevalent in the region of Pacific and Atlantic, almost absent in the region of Indian Ocean. So this is why even equatorial westerlies also come into existence. I hope this portion is understood. I hope this portion is something which is internalized. Now, coming back to this, so here, water basically is brought forward by the north equatorial current, and owing to the shape of the coastline, observe, water will be diverted, right? Now here, the water current comes across obstacles in the form of the Antilles Island, the Caribbean group of islands. So that means the current gets divided into two portions. One goes from the north of the island, other goes from the south of the island, known as Caribbean current, right? Now, as this one moves from the south of these Caribbean islands, they enter into the region of Gulf of Mexico through a narrow opening here. Here you have a kind of a peninsula. What is the name of this peninsula? This is your Yucatan Peninsula, right? Present in the region of North America and the region around Gulf of Mexico. This is your Yucatan Peninsula. So that is when water basically moves in and circulates through the Gulf of Mexico. From the Gulf of Mexico around the region of the state of Florida in US, this is the state of Florida, that is where the water exits. This is where it is known as the Florida current, owing to the name. Now, as this Florida current basically comes out, it is joined by the water current, which was coming from the north of the Caribbean group of islands. So you have two warm currents now coming together. Now, basically, excuse me, basically, both these currents, their water will get added up. And their origin appears to be from the region of Gulf of Mexico. An individual standing here, for that individual, this current is coming from Gulf of Mexico. That individual will never trace it back that North Equatorial current actually became Caribbean current, then it became Florida current, and then we are receiving this. No. For that individual, it appears to be originating from Gulf of Mexico. And hence, both the Florida current and the ocean current to the north of the Caribbean islands, they join together to form one of the most powerful warm currents in the globe. That is your Gulf Stream. So Gulf Stream gets generated. Gulf Stream gets into action. This is very, very strong. If in a day, it manages to move millions of gallons of water from one place to another. Now, aided by the shape of the coastline, also the Coriolis force, you will observe that the Gulf Stream also takes a rightward bend. In the meanwhile, the Gulf Stream is joined by a cold current coming from higher latitudes. That is the Labrador current. So, this is a cold current which comes from the higher latitudes. Now, here you might have a question, and which is quite natural, that We talk about the presence of ocean currents because warm water gets inflated, so it can be carried away. But why is it that we are getting current from the region of Greenland, northern Canada, which is so very cold? How come we are getting the currents from there? So, mind you, there also you have permanent wind system. You have in presence the polar easterlies. So polar easterlies, along with the shape of the coastline, that influences the existence and in fact creates these particular cold currents. And these cold currents, first of all, the Labrador current mixes with the Gulf Stream around the region of the area of Newfoundland or northeastern part of North America. That is where you will find the Labrador current mixing and meeting with the Gulf Stream. Now, wherever you have the warm and cold oceanic water meeting each other, mixing with each other, those regions, they get significantly enriched with dissolved oxygen. And in those areas, you will observe that the count of fishes goes up significantly. So these form the richest and the best fishing grounds across the world, wherever warm and cold ocean currents meet. So, meeting of warm and cold ocean currents. Cold ocean currents creates best fishing ground of the world. Okay, so this is a region which is very rich in fisheries. Nonetheless, Gulf Stream is so very powerful that it maintains its original property, it maintains its intensity, it maintains its characteristic of being warm as well. Because, mind you, Gulf Stream is bringing water from the lower latitude to the higher latitude, so it will be warm. Now, in the region around 50 degree, 60 degree, which is the permanent wind system in place? The westerlies. Westerlies blow from which direction to which direction? West to east. So these westerlies, they help in dragging the Gulf Stream further along. And that is when, for some portion, it is referred to as west wind drift, but then it is referred to as North Atlantic drift. Right? This is where this is named as North Atlantic drift because it is present in North Atlantic. But why the term stream, then current, then drift? What is the meaning of that? So all of these, they designate the speed at which the water is moving. Drift is when the water is moving the slowest, when it is moving purely because of some slow wind movement on top of it, water is moving along with that. So that is drift. Stream is when you have a regularized flow, right? Current also, you have a comparatively faster movement. So that is why when you come across drift, means it is not flowing very fast. But nonetheless, this North Atlantic drift is nothing but a portion of the Gulf Stream, which has reached further northwards. So that is why North Atlantic drift is a warm ocean current. Now, this North Atlantic drift, as we have seen earlier, it encounters the mid Atlantic ridge, that is the Wyville Thompson Ridge in this area. And that is when it gets divided into multiple branches. And then, owing to the shape of the coastline, one portion goes across the region of the Scandinavian countries, that is your Norwegian current. One portion, it enters the Bay of Biscay, here moves through here. Another portion, also some portion of it enters here also in Mediterranean. So you have multiple different sub-classification of the North Atlantic drift as well, that is Irminger, Rennell, etc., not required for your general studies. So here, the North Atlantic drift, basically, it moves further north in the form of Norwegian current. That Norwegian current will also be warm. because it is bringing water from the lower latitudes again, right? And this is one of the reasons why this region, Norwegian coastline, etc., that tends to remain ice free through most of the year. Okay. Meanwhile, as these currents are moving, they will take another rightward bend owing to the Coriolis force and also owing to the shape of the coastline. Now they are coming here in the direction of the lower latitudes. So that means they are carrying water from higher latitude to the region of lower latitude. Here it might be possible that the temperature of North Atlantic drift, let's suppose, is 15 degrees Celsius. Remember the earlier example. Let's suppose the temperature of North Atlantic drift is 15 degrees Celsius. So in comparison to the water at such high latitude, North Atlantic drift will be warm current, right? But when that 15 degrees Celsius water reaches the lower latitude, it will be cold current. And that is where, to the to the west of Africa, near the Canary Islands, you have the same ocean current being termed as the cold current because it is colder than the surrounding water. And you have the cold Canary current, which is generated out of it. So that is how you have the entire circulation which is fed, and that cold Canary current provides water back to the North Equatorial current once again. Okay. So I will repeat the entire process once again. I want you to pay attention once again. Let this get cemented in your mind, brain, memory, wherever you are storing information, whichever part of your body. Let this get ingrained there. So, listen to this carefully again. Around the region of equator, you have significant amount of heating. Due to that significant and substantial heating, water tends to expand a bit. As water tends to expand a bit, after that, the role of the winds, they come into place. Now, there you have the presence of trade wind systems. And these trade winds, they basically carry the water from a direction of east to west. Now, water is carried in the direction of east to west in the form of north equatorial current, south equatorial current. That means there is a significant amount of water which is accumulated here around the region of equator, right? Significant and substantial amount of water which is accumulated there. Now that accumulated water has a kind of a flow in the west to east direction, owing to the presence of the rotation of planet earth on its axis in west to east direction. That provides the momentum to push the water in the eastward direction. Along with that, you have an associated weaker wind movement also, what is referred to as equatorial westerlies, which is largely present in Atlantic and Pacific, mostly absent around Indian Ocean. Now then, here you have water which moves in opposite direction as compared to the north equatorial and south equatorial current, and that is why it is also referred to as counter equatorial current. Now, as this north equatorial current basically it encounters the Caribbean islands. Now it gets bifurcated or divided into two. One portion goes through the north of these islands, another portion goes to the south of these. The portion which goes to the south of these islands, that current enters through the region of the Yucatan Peninsula into the Gulf of Mexico. It is this warm current reaching the Gulf of Mexico, due to which Gulf of Mexico is also a center for very active uh, cyclonic formation. There also, in Gulf of Mexico also, you have very frequent cyclonic formation which is observed. Nonetheless, this Caribbean current enters into Gulf of Mexico, exits from the region of Florida, and as it exits, it meets this warm current which is coming from the north of the Caribbean islands. So that means that now the warm current has become much more powerful, much more stronger. And as it has become much more powerful and stronger, that is when you have the generation of the Gulf Stream. Gulf Stream is one of the most powerful warm water currents that you have. Now, that Gulf Stream starts moving northwards, aided by the shape of the coastline and also the Coriolis factor, due to which it starts bending to the right. Meanwhile, from the higher latitudes, you have generation of cold current in the form of Labrador, Greenland, etc. But the most substantial or influential out of them is the Labrador current. Now, that Labrador current, it meets the warm Gulf Stream in the region around Newfoundland in northeastern part of North America. Now, here is where the mixing of the warm and the cold ocean water takes place. Wherever you have the mixing of the warm and the cold ocean water taking place, those regions end up becoming very ideal fishing grounds. So that is why these are very ideal fishing grounds, one of the richest fishing grounds out there in the world. Now, furthermore, the presence of westerlies, it carries that Gulf Stream water from west to east. That is when momentarily it is known as the west wind drift, but after that it is known as the North Atlantic drift. That North Atlantic drift, it encounters the mid-oceanic ridge in the form of Weivel-Thomson ridge. It encounters the different type of coastline of Western Europe. It gets divided into multiple portions. One of them even enters into the region of Norway. And you have the warm Norwegian current, which keeps the region ice-free for most of the year as well. In the meanwhile, this west wind drift further bends rightwards due to the Coriolis force. And now you have water which is being brought from the higher latitude to the lower latitude. Remember what we had talked about in the case of the warm and cold ocean currents? That whenever water is being brought from higher to lower latitude, it is generally colder water, because water temperature at higher latitude will always be lesser. Water temperature at lower latitude, it will be higher. Right? Water at lower latitude comparatively will be warmer. So here let's assume the temperature of this west wind drift or the North Atlantic drift, even if the temperature is 15 degrees Celsius, right? Now temperature at the of the water in tropics, if it is 24 degrees Celsius, so the water when it is brought from, and the water temperature is 15 degrees Celsius in the region of equator, it will be deemed as a cold current. That is why the Canary current is a cold current. Right? Also apply the same logic here that we applied in the case of a warm current, that they are found on the east coast of the continents. Why? Why on the east coast of continents do you have the presence of, or rather, cold currents? They are found on the west coast of the continents. Why? Because of upwelling, right? So here on the west coast of Africa also, because of the action of the trade winds, you will have colder water in general. Hence, the Canary current will be cold. And you have the Canary current resupplying water into the North Equatorial current, and the entire cycle is complete. Is that portion understood? Or do we have any doubts? Krishna, is your doubt now clear? You had a doubt that why Canary current is cold? Okay, good. So I'm presuming no doubt as of now. Welcome to Sargasso Sea. Whatever we have said, whatever we have talked about till now, is that understood? Good. Akshay, it would be good if you can make a flowchart diagram, flow diagram type. So do one thing, Akshay. That is something that you can do on your own as well, right? Try doing it on your own. It is fun. And west wind drift. West wind drift is basically when you have the Gulf Stream further carried in the west to east direction with the help of westerlies. That is what you have as the west wind drift. Okay. So west wind drift is also present in the Pacific Ocean also. So that is your west wind drift. Okay. Yes. See, west wind drift is created due to the presence of westerlies. So it will be present in southern hemisphere also. West wind drift that is created due to westerlies. Westerlies. Okay. So westerlies will be in existence in southern hemisphere also. So westerlies will be in existence in Pacific Ocean also. Observe in Pacific Ocean also. Here for some extent you have the west wind drift and then the North Pacific current. Here you have west wind drift in the southern hemisphere. In Indian Ocean also, observe in the southern hemisphere you have the presence of the west wind drift. Okay. Yes, Akshay, please do send a mail in that case. And Anuranjan, I have remembered all the names of Atlantic Ocean currents by drawing 5 to 6 times the map on whiteboard. That is the approach which is required. Very good, Anuranjan. Beautiful. And current, stream versus current. So when you have the presence of a stream, current, or a drift, that basically is representative of the amount of water which is moved. So in general, the streams or the currents are very fast, streams are slightly slower, drift is very, very slow. Okay. But sometimes stream basically is the one which can carry large volumes of water. The amount of water carried by the streams is generally higher. Okay. In answer to the paper, wants to draw the land along with the flowchart of the ocean current. Yes. Counter equatorial current brought back less water. Yes. In comparison to the water which was actually accumulated in the western portion, counter equatorial current brings some amount of lesser water. Okay. Is Canary current going to reduce the Mediterranean sea temperature? Not so much. You have some portion of the North Atlantic drift in itself which enters through the Strait of Gibraltar and enters into Mediterranean. And I also have command over world map making now. It's just a task of 5 seconds. That is very, very impressive. Very nice. Okay, so I think I have addressed all the doubts. I don't think any doubt has been left over. Good. My mail ID. I think I shared it already, but nonetheless, this is my mail ID. Okay. Yes, Priya, as of now. Now, after this, I think the mail ID is more than clear. Now, let us come to the southern hemisphere in the Atlantic. Let us take a look at what happens in the southern hemisphere. As I had told you, that the basic principle involved is very same. It is one and the same. So, what is the principle involved here? So, here also you will have the presence of these trade winds. These trade winds, they will push the water just like north equatorial current in the northern hemisphere. Here also you will have south equatorial current in the southern hemisphere. Meanwhile, some amount of water will get accumulated across the western portion of Atlantic, which will flow back in the form of counter equatorial current. So counter equatorial current is created. Why? Because of rotation of planet on its axis, accumulation of water. Both of these factors are responsible, isn't it? But rotation much more so. Now, here you will observe that this south equatorial current, aided by the shape of the Brazilian coastline, it starts drifting or it starts moving leftwards, and then also the Coriolis force kicks in. The Coriolis force basically will bend any moving object in leftward direction in the southern hemisphere, will bend any moving object in the rightward direction in northern hemisphere. So as the Coriolis force kicks in, you have the warm Brazil current. There you had the warm Gulf Stream. Here you have the warm Brazil current. But Brazil current is nowhere as strong as Gulf Stream in terms of the amount of water that it brings, the amount of water that it carries. Meanwhile, all across the Southern Ocean, you will have very prominent movement of westerlies. Very strong movement of westerlies all across the southern ocean, right? So that movement of westerlies will drag water all through the region around the southern ocean from a west to east direction. So you will have west wind drift in the Atlantic, in the Pacific, in the southern hemisphere, and also observe the southern part of Indian Ocean. There also you will have the prominence or the presence of this west wind drift there also, right? So this west wind drift will be consistent through and through. Now, after this, meanwhile, as this west wind drift is moving across the planet in the southern hemisphere in a portion from west to east direction aided by the westerlies, some part of it near the Falkland Islands here. I hope we are aware of the Falkland Islands, right? In case you are not aware about it, and in case you are interested in military warfare and those kind of information, that how uh, wars have been won in history, do read about the Falkland War. It is one of the most ingenious modern military warfare techniques where UK or Britain, all the way from here, managed to launch an aerial attack in the region of the Falkland Island, obviously with the help of aircraft carriers. Those aircraft carriers was later acquired by India also. So it is very interesting, the Falkland War. It was, some portion of it was also named as Operation Goa. So that is where it becomes very intriguing. But nonetheless, near the region of Falkland Islands, this a part of west wind drift, it bends to the left because it is the southern hemisphere. It is the portion of the leftward movement due to Coriolis force. So here also you will have a meeting of the warm and cold ocean current, but it will no way be as strong as the Gulf Stream and the Labrador current, because Gulf Stream is carrying enormous amount of water. Labrador current is also comparatively stronger as compared to Falkland current. So that is why much more ideal fishing ground will be created in the northern hemisphere as compared to the region of the southern hemisphere. Nonetheless, as this west wind drift moves, again, there will be a leftward movement, the leftward bending from the southwestern coast of Africa, and you will have a cold Venezuela current. Why cold? Because it is bringing water from higher latitude to lower latitude. Water temperature will always be colder at higher latitude as compared to lower latitude. So it brings colder water from higher latitude to lower latitude, and it again completes the circulation as south equatorial current. So that is how you have a complete circulation in the southern Atlantic Ocean. Is that understood? West wind drift is not across the Indian Ocean. It is present across Indian Ocean also. Drishti, observe here. West wind drift is here. West wind drift is also here. It is present across everywhere. Is that portion understood? Good. So that is the principle behind ocean currents in the northern and the southern hemisphere. Now, the same principle, the same mechanism can be implemented in the Pacific also. The same mechanism can be implemented in the Indian Ocean also. Let us see how. So when we talk about the Pacific Ocean, it is almost very similar. Just the difference is the Pacific is much more wider as compared to the Atlantic. Okay. So here, Pacific Ocean. I will come to Sargasso Sea. Don't worry. I have not forgotten Sargasso Sea. Okay. Once again, I will quickly repeat the southern hemisphere. So in the southern hemisphere, what happens? Here also around the region of equator, you have accumulation of water, warm water, and accumulation because of heating, and that has led to expansion of water. Now that water is ready to flow. Direction will be provided by the wind systems. Now you have the trade winds which blow continuously from east to west. So these trade winds will take up that inflated water westward in the form of south equatorial current. That south equatorial current, aided by the shape of the Brazilian coastline and the Coriolis force, bends leftwards. And then it moves southwards in the form of the warm Brazil current. Now, this Brazil current interacts with an offshoot of the west wind drift in the form of Falkland current. West wind drift is a continuous movement of water in the Southern Ocean owing to the higher impact created by the westerlies. That is where you have the presence of west wind drift. So, because we are in southern hemisphere, there is a leftward bending. So, you have in the region between the Falkland Islands and the mainland, you have the generation of a cold ocean current which passes through there, and you have the cold Falkland current which meets the Brazil current. The Brazilian current is subsumed in the west wind drift, and some portion of that west wind drift again bends leftward from the southwestern coastline of Africa and then resupplies that water closer to the equatorial region in the form of cold Beniguela current. Why it is referred to as a cold current? Because it is bringing water from higher latitude to lower latitude. So that is one of the reasons why it will be regarded as a cold ocean current. Okay, is that understood? Shahid, Falkland is also a rich fish. It is a very good fishing ground, but not as rich as what you observe in the region of Newfoundland between Gulf Stream and Labrador Current. Okay. Now, when we talk about the region of the Pacific, again, the same principle. I will show you the analogy with the Atlantic also. Here also, you will have the trade winds moving from east to west continuously, right? So they will be pushing up the warm water in the form of north equatorial and south equatorial current. That water will be moving in a direction of east to west. Okay, let's talk only about the northern hemisphere as of now. So as this north equatorial current further moves over, eventually aided by all the hundreds and thousands of islands that are present here, it is shaped and bends rightwards and northwards. Here, it gets divided into a minor Tsushima current from the eastern portion, from the western portion around Japan, and Kuroshio current, that is warm current, which gets present in the east coast of Japan. Right? Just like you had Gulf Stream there in the Atlantic, here you have the presence of Kuroshio current. Now, this Kuroshio current ends up meeting with the very cold Oyashio current, which is coming from the region around Bering Sea, Bering Strait. Right? So that Oyashio and Kuroshio meet. There also, you have the creation of ideal fishing ground. Okay. Now, meanwhile, this ocean current, that is the Kuroshio, is carried further westward with the help of the westerlies. Its temperature is going to be higher because it is bringing water from the lower latitude. And then it is known as the North Pacific current. North Pacific current. There it was North Atlantic drift. Here it is North Pacific current, meaning that the speed here is higher in comparison to the North Atlantic drift. Here the speed is higher. So this North Pacific current then encounters the obstruction in the form of the North American landmass. It gets bifurcated into two. Here, one portion goes into higher latitudes, that is the region around Alaska, etc., where in general the temperature is so low that this Alaska current is regarded as a warm ocean current. This becomes a warm ocean current, right? But the same ocean current, when it brings water to the lower latitudes, comparatively, it is much colder than the surrounding water of the tropics of the equator, because the water temperature at the tropics or equator is around 24, 25. Even if the temperature here is 10, 12, 15, 18, anywhere, it will still be colder. So that is when, just like you had the cold Canary current, here you have the cold California current, which is generated. So like that, you have the entire circulation happening in the northern portion of Pacific. When we come to the southern portion of Pacific, here again, you have the South Equatorial Current carrying on the same purpose. Carrying with the help of the trade winds, the South Equatorial Current carries warm water from the region of Eastern Pacific to the region of Western Pacific. Some portion of that warm water even penetrates into the portion of or the region of Indian Ocean in what we refer to as a weak Lewin current. In the form of a weak Lewin current, some portion enters into Indian Ocean also. That brings many of the times warmer conditions of the Pacific to be reflected in the warming of Indian Ocean also. Nonetheless, just like in the case of the southern Atlantic, we had the Brazil current, the warm Brazil current. Here you have the warm East Australia current. Okay. Then again, in the Southern Ocean, you have the perpetual presence of the west wind drift, and that East Australia current basically goes along with the west wind drift. This west wind drift takes a leftward bend owing to the shape of the coastline and the Coriolis force of South America in that region. And that is where it generates what is referred to as the Peru current or the Humboldt current. This is also what is referred to as Humboldt current. Okay. This cold Peru current, just like you had the cold Beniguela current in the case of Southern Atlantic, here you have the cold Peru current. Okay. So that also brings about a complete circulation, and you have the entire circulation completed in the Southern Pacific. Okay. Let me take few questions now. Current west wind drift in north is hot and in south it is cold, because in south you have the in the southern hemisphere you have the entire west wind drift being present in the southern ocean, that is the water body surrounding Antarctica. So that is where the impact of these westerlies aided by the cold temperature is retained. Whereas when you and also many portions from the region around Antarctica, islands from around Antarctica, polar easterlies, they keep on supplying that cold water. That is why westward drift is colder. Whereas in the northern hemisphere, it is the Gulf Stream, it is the Kuroshio current. These supply the water to the west wind drift. That is why it is warmer. Okay. Here also fishing zone is very good. Yes, Kuroshio and Oyashio, there also fishing zone is very good. And think about it. Apply your logic. Look at the staple diet in Japan or the general Japanese cuisine. Those of you, I don't know how many of you like Japanese cuisine, but an important part of Japanese cuisine is the presence of different forms and varieties of fish, right? You don't have a staple food in a region unless and until that food is found in abundance. That is why you can apply your logic or by method of induction this way or that way. This is a very good and rich fishing ground. And Pranay, I found that west wind drift is continuous in southern hemisphere compared because of presence of land. Yes, correct. Drishti, is it weak Lewin current? Yes. Lewin current is not very strong in terms of either the speed or the amount of water which is carried, right? So that is why very slowly and steadily, not aided by the wind movement in particular, but aided by the ocean dynamics here, they get channelized in between these islands and enter into Indian Ocean. And Shiva, can we say that during La Nina, North Equatorial current gets stronger, while during El Nino, counter equatorial current gets stronger? Very nice. Yes. But what I would suggest to you, during La Nina, both the equatorial currents get stronger, north as well as south. During El Nino, you have the counter equatorial current which gets stronger. And now that you are aware of it, let me also tell you, during El Nino, you also have a substantial weakening of the Humboldt current or the cold Peru current, right? Because it is only by the weakening of that cold current that you have the generation of the low pressure. So the atmospheric factors in this area, they also end up weakening the cold current of the Peruvian coastline in certain cases. But many of the times, that weakening of the cold Peru current happens because of the heating of the southern Pacific. And when the southern Pacific starts experiencing higher temperature, that is when this cold current becomes weaker, and that is when conditions are ripe for El Nino. Very good. Nice deduction. And Surbi, very innocent question, my dear friend. What is the class timing? Class timing, actually, today we started at 11 and we will be ending at 8. Tomorrow we'll be starting at 10 and we'll be ending at 8. Um, Here also best fishing grounds, yes. And how Peru currents weaken by heating of the Pacific. When the Pacific in general gets heated up, you have water in even the higher latitudes which become slightly hotter. So you don't have those cold water coming in anymore. So their flow becomes intermittent. That in itself is sufficient. Uh, Anuranjan, all currents flowing from lower to higher latitude are warm. Yes, except Alaska. Alaska current also moves from lower latitude to higher latitude. Alaska current moves from lower latitude to higher latitude. Don't get diverted by this arrow mark, because that arrow mark is created due to the shape of the coastline. The shape is such that the water gets recirculated like that. Okay. Akshay, is this the only reason we see formation of fishing grounds in Kolkata region and in South Indian coastal areas? No. In Kolkata, the fishing ground that is present, so you don't have that kind of a marine fishing ground created in Kolkata. For in case you are aware, in Kolkata, what is the maximum type of fishes which are caught? They are basically your freshwater fishes. So as you have various varieties, such as one of the specialties of that region is the hilsa fish, or what is referred to as the Ilish fish. So that hilsa fish, just like salmon, you would have heard about salmon. So just like salmon, it basically travels upstream of the river in order to lay eggs. So that is where it is caught in the region around the Hooghly River. But after construction of the Farakka barrage, even that has reduced quite significantly. So that is one of the major catches in Kolkata. Okay. If you are talking about the staple food, that is a different matter altogether, because the consumption of fish is very high in the coastal areas because of ease of availability, and in the eastern areas consumption of fish is very high because almost 2 to 3 months throughout the year, majority of these regions historically have suffered from significant amount of flood, very high amount of flood. So the regions which experience very high events of or occurrence of flood, in that area rice can grow very easily. That is why rice is a staple diet in eastern part of India also. And also, crops won't grow very easily, you will have fish availability. That is why it becomes a part of the staple diet. But nonetheless, that is a different topic altogether. uh, which current will be more stronger, equatorial or counter equatorial? Always equatorial. Always equatorial. Counter equatorial, Puja, what happens in the case of counter equatorial is that you have all the warm water which gets accumulated here. Observe this image. All the warm water, with the help of the trade winds, they get pushed in the westward direction. Now that warm water will get accumulated here. Some portion will get diverted, some portion will get diverted here, some portion will get accumulated. What will happen to the accumulated water? So that is where we have to also give cognizance to the fact that planet Earth continuously, with a substantial amount of velocity, keeps rotating from west to east. So in case you have some accumulated water here, it will also have a tendency to move eastwards, owing to the momentum or the inertia provided by the rotation of the planet in west to east. That is why you will observe or you will experience basically all that water to move in a direction eastward. That is your counter equatorial current. Is that understood? Now, What is the principle is there for Bermuda Triangle mystery? I think you missed the first class of geography that we had, where I begged forgiveness that UPSC also does not ask, that I won't be able to solve questions in three areas. Three areas are where I will have an absolute incapacity to solve the questions. One is Bermuda Triangle, second is Ram Setu, and whether Ram Setu really did exist or not. And the third is what happens in Kailash Mountains, whether there is a spiritual supernatural power going on there or not. So, and also about Dwarka, whether indeed there is an ancient landmass which has basically been subsumed by the sea. So, all these kind of mythological, mysterious, conspiratory theories kind of principles, I'm very weak in that. So, I'll beg your forgiveness in that. But let me assure you that UPSC is also not interested in these questions. These are the particular topics from which you will have various content creators in YouTube making a name and fame for themselves. So you have a lot of videos on that. You can watch it on. So apologies in that regards. Now we come over to the Indian Ocean. Now, Indian Ocean is unique in the sense that when you take a look at the northern portion of the Indian Ocean, it is different as compared to the northern portion of the Pacific, northern portion of the Atlantic also. Because in both these cases, the northern portion is open, right? Whereas in Indian Ocean, northern Indian Ocean is where it is closed by landmass. Okay. So northern Indian Ocean is not very big. It is basically two seas are there, Arabian Sea, Bay of Bengal. You don't have a large Indian Ocean in the northern portion or the northern hemisphere, is it? So that is why in the northern Indian Ocean, you experience seasonal reversal of the ocean currents because of seasonal reversal of the wind direction and the wind pattern. So in northern Indian Ocean, seasonal reversal of wind movement along with or rather ocean currents along with seasonal reversal of winds. Or due to the seasonal reversal of winds that is observed. For example, in the month of May, June, July, right? In the month of May to July. Here, what is the wind direction? The wind direction during this time is basically like this. That is your wind direction, isn't it? So that is why in the northern Indian Ocean, at that point of time, you will observe the water also dragged in the same direction. You will have a clockwise circulation during the advancing monsoon. So during the advancing monsoons, wind direction is southwest to northeast. So even the ocean currents become clockwise. And here, by the way, UPSC has asked this question in the mains examination for general studies twice. And the framing of the question is very similar that I told you earlier, that what are ocean currents? Discuss about the uniqueness of ocean currents in northern Indian Ocean. So all that UPSC is trying to judge or is trying to check out of you is whether you are comfortable, whether you are aware of that variation in northern Indian Ocean as compared to the other oceans, right? So these kind of questions are generally asked. Now, what is the reason? Why is it that there is reversal? Because northern Indian Ocean is very, very small, and that means the influence of the wind in this small region is much more greater. Influence of wind, what influence? The dragging ability of the wind when it comes to the water. So if in a small area the wind speed sudden or the wind direction suddenly changes, it will significantly alter the direction of the water movement as well, right? So that is the reason why you have the alteration or the complete reversal of oceanic current movement in the northern Indian Ocean. It is very, very small, hence the impact of wind gets exaggerated. Then during the time of the northeast monsoon, let's say November to Jan, Feb, the wind direction is northeast to southwest. So that is why even the circulation that is generated, even that circulation that you will observe will be counterclockwise. So here, during the time of the northeast monsoon, wind direction northeast to southwest, and also ocean current will be counterclockwise. Whereas in the southern hemisphere, everything goes as per plan, everything goes as you observe in the southern Atlantic and southern Pacific, where you have a south equatorial current which gets bent in the leftward direction owing to the shape of the coastline as well. Here you have a Mozambique current and another one that is the Agulhas current. Now they get subsumed in the west wind drift. Furthermore, the west wind drift bends leftwards. Just like you had cold Peru current in Pacific, you had cold Venezuela current in Atlantic. Here you have the cold West Australian current in the Indian Ocean. So that West Australian current, in a way, the weak Leuven current which is there, which is bringing water from the Pacific. So that Leuven current, in a way, briefly encounters or mixes with the West Australian current, but it is almost negligible. So it is not a very ideal or a very good fishing ground for that matter. It is simply there. Most of the Leuven current oftentimes is generated. Oftentimes that Leuven current gets supplied to the region around central Indian Ocean. So it is not a major factor here. But nonetheless, that West Australian current, the cold West Australian current, goes and empties its water again in the central Indian Ocean. So that is how you have a complete circulation. Okay. Um, Counter equatorial current does not have flow in May or July, not significantly, no, because during the month of May and July, during the months between the monsoons or during the time of the advancing monsoon, the ITCZ also advances somewhere here, right? So here you don't have that much amount of accumulated water, first of all, entering into this area that it can flow back, right? Because if you observe, the direction of water movement is very different. Whereas in the month of November to January, that is when you have the accumulation of water here which can flow back, and that is why even the equatorial westerlies, they will be present in the month of November to January. Understood, Gaurav? Parshuram, May July monsoon is more effective than November Jan monsoon any day, always. Pranay, can we take can we say ocean currents in North Indian Ocean is influenced by landmass heating or cooling? No. Influenced by the wind direction, right? Influenced by the wind and the proximity to the landmass, the closeness with which the landmass is present. Till now, any doubts that we have? Absolutely any kind of doubts that we have? No? Okay. So, with that, I hope and I presume you'll be able to frame answers in this whenever and wherever required. Now, we elevate. I will come to Sargasso Sea, by the way. I have not ignored Sargasso Sea. So, now we come over to another circulation. But this is a circulation which goes on across the entire globe. This is a circulation which is also referred to as global conveyor belt. Conveyor belt. I hope we know what is a conveyor belt, right? I hope everybody is aware of that. Something that you use in industries, in your malls, everywhere. A conveyor belt is basically like this, right? Where you have a motion like this, right? So when we say a global conveyor belt, oceanic water across the globe, that tends to mix with each other. That tends to basically interact with each other. And the movement of this oceanic water is driven by the principles of thermohaline circulation. So, as you will observe here in this image, the warm surface water, even though it is a kind of a representational image, so this portion of warm surface water that you see, it actually has to go somewhere around this area. Why it is indicated here? So that you are able to see subsurface current. But it goes around somewhere like this. Gulf Stream is a part of this global conveyor belt. So this warm water moves to the higher latitude. It loses temperature, cools down, and as it cools down, it passes on as subsurface current. Some portion of it rises around the region of equatorial Atlantic. Other portion of it enters into other oceans. It is a subsurface current as it is moving. Wherever it heats up or warms up, it rises and comes back to the surface. Otherwise, you have a complete circulation. It rises, comes back to the surface. Right. Now, this entire circulation, it basically achieves two objectives. First is distribution of heat across the entirety of the planet. From the heat surplus to a heat deficit area, you have distribution of heat. And second purpose, which is fulfilled here, is basically where you observe again the distribution of nutrients across the various oceans, the availability and the presence of nutrients that is also ensured, which is very beneficial for the marine species. Now, out of this entire global conveyor belt, the portion of the Atlantic that portion of Atlantic, this circulation happening in the portion of Atlantic, that is what is referred to as AMOC or Atlantic Meridional Overturning Circulation. But why is the name so complicated? Atlantic Meridional Overturning Circulation. Couldn't we simply have said Atlantic Circulation? So here it represents meridional, means derived from the term meridian. So basically, across a similar meridian or longitude, you have the water which is going, sinking, coming back. You don't have much longitudinal variation here, right? And overturning, because the warm water is going to the surface, from the surface, it is cooling down, it is sinking, and then coming back. So there is a kind of an overturning. So hence, you have the name Atlantic Meridional Overturning Circulation, which is a part of the global conveyor belt system. So, first of all, the global conveyor belt is a system of ocean currents that transports water around the world. While winds primarily propel surface currents, Deep currents are driven by differences in water densities in a process called thermohaline circulation. Right? Density depends both on temperature as well as salinity of water. So, along this conveyor belt, heat and nutrients are moved around the world in a 1,000-year cycle. So, what does that mean? That water, let's suppose, which is present in the Atlantic, for it to recirculate and come back into that entire region again, it can take a good span of 1,000 years. It is only for the past 70, 80 years that we have been observing this overturning circulation or this conveyor belt system. But it is very essential for maintaining the nutrition cover of the oceans across the entirety of the globe. Now, here, when you talk about it, the ocean conveyor belt describes the interaction of surface currents like the Gulf Stream and deep, slow moving underwater currents across all ocean basins. They mix ocean water, salt, and even organisms on a global scale. As ocean temperature and density contribute to temperature change in the atmosphere, ocean conveyor belt also contributes enormously to the climate of our planet. You have Gulf Stream, which is a part of AMOC, that is Atlantic Meridional Overturning Circulation. As warm Gulf water approaches the North Atlantic, it cools, releasing its heat to the atmosphere. As it cools, water becomes more salty and dense, thereby it sinks to the bottom of the ocean. Gulf Stream and AMOC are a part of the larger ocean conveyor belt. Now, this is something which is relevant for your portion of current affairs of your geography syllabus. Every year, every other year at least, you will find this portion to be in discussion somewhere or the other. Now, due to climate change, what is happening is that the Gulf Stream is actually slowing down. So, due to climate change, not only this conveyor belt, the AMOC is slowing down, right? So, due to climate change, AMOC is slowing down. This impacts the temperature of the area. How? So let's suppose you consider the water, oceanic water in the higher latitudes. Now the warm Gulf Stream water, the Gulf Stream would bring warmer waters, isn't it? So the Gulf Stream would bring warmer waters. And eventually, upon reaching higher latitude, it would cool down. When it would cool down, it would release heat into the atmosphere, isn't it? And that heat in the atmosphere would basically lead to some amount of evaporation and would bring about precipitation in the region of Europe. Okay, so under normal conditions, let me write it down here. So basically, it cools, releasing heat to the atmosphere, and this heat to the atmosphere under normal conditions, this heat would provide vapors, water vapor in atmosphere, and leading to rains in Europe. But due to climate change, what is happening is that the sea surface temperature is increasing. Sea surface temperature is increasing not only in lower latitude, but also in higher latitude. Closer to the region of the poles, the sea surface temperature is increasing. What that means is that the Gulf Stream is not cooling down anymore. Okay, so due to climate change, as we see, due to climate change, the AMOC is slowing down. Why? So here, with rise of sea surface temperature, AMOC is not slowing down, or rather, Gulf Stream is not cooling down anymore. So, as the Gulf Stream is not cooling down anymore, it is retaining a higher temperature. So, that means, will it sink? No, it won't sink. So, it stays in the same region for a longer period of time. When the water stays in the same region for a longer period of time, it continues to receive heat from solar insolation for a prolonged duration. So, what happens? Water temperature begins to increase, and that creates conditions for storms and cyclones. This is the reason why Atlantic is experiencing very high frequency of cyclones in the past few years. Because as this entire AMOC is slowing down, this entire circulation which was happening, that entire circulation has stopped. So means water wherever it is present is exposed to high amount of solar insolation. And that high amount of solar insolation means there is substantial amount of heating. And that means more frequent occurrence of storms and cyclones. So here, more frequent occurrence of storms and cyclones. Okay. So rather than a normal rainfall, regular rainfall in Europe, now Europe is experiencing drier conditions with frequent occurrence of storms. So that is why you have heat waves followed by floods, again followed by long heat waves, again followed by floods. So that is how a slowing oceanic circulation will have an impact on the global climate as well. Okay. Now, after this, we come to the effects of ocean current in terms of the climate, in terms of the region around them. For example, when we talk about the ocean currents, so the mixing of warm and old ocean currents, they help replenish the oxygen quantity in the water, and these create very ideal fishing grounds. So that is why where Kuroshio, Oyashio meet, where Gulf Stream, Labrador current meet, these are your very ideal conditions for fishing. And similarly, when we talk about the areas, so best fishing grounds in the world exist mainly in these zones of warm and cold ocean currents. Other than that, these ocean currents, by the way, as rightly pointed out, they are also responsible wherever warm and cold ocean currents meet. There is generation of massive fog. Why? Remember when we talked about the fact that warm ocean current means warmer air above it, or let me represent it. So let's suppose you have colder ocean water which is coming in a region, and then you have warmer ocean water also coming in. So this is your warm, this is your cold. So here you will have warm air, here you will have cold air. So when that warm air and cold air will meet, there will be condensation. And in this area, you will experience the heavy fog formation, very heavy sea fog, which is a nightmare for the navigation. For the shipping industry, it is virtually a kind of a nightmare. Okay. Now, these ocean currents, by the way, if you would observe, then in the Atlantic, you have the cold Venezuela current. In the Pacific, you have the cold Peru current. In the Indian Ocean, you have the cold West Australia current. Now, all these currents, wherever they are present, closer to the land, you will have the presence of deserts. Okay. So, cold ocean currents are responsible for creation of deserts in the western margin of the continents. Why and how? So, here again, if you think about it, yes, Pranay, this is a kind of an advection fog, and this is because of temperature inversion. Very good. So here, when you have, let's suppose, a landmass, okay, and here you have the presence of water, which is very cold. So when the water is very cold, in the case of the cold current, so the air above it will also become very cold, right? So above it, if even if the air is warmer in this region, you will experience what? Condition of inversion, condition of temperature inversion, and that is associated with lack of rainfall, lack of rains, and these lack of rains create deserts. Examples: in the region of South America, you have the Atacama Desert. In the region of Africa, you have the Kalahari and the Botswana, the deserts. Then in the region of Australia, you have the Victoria Desert. All these deserts, they get created because of the presence of cold ocean currents nearby. Okay, I hope nobody will ask the question that Thar Desert, is Thar Desert also created like this? No, because nowhere near Thar Desert you have any existence of cold ocean current, even by the farthest proportions. So that is how you have the deserts created across the western margin of continents due to these cold ocean currents. Okay. Now, then comes Sargasso Sea. Now, Sargasso Sea, generally when you talk about sea, seas are present at the margins of the oceans, generally surrounded by land masses from one side, two side, three sides, or so on. But they are present at the margin, at the vicinities of the oceans. Now, Sargasso Sea is the only sea where it has got no land mass nearby. Sargasso Sea is very unique. It was discovered way back in the 1400s by the Portuguese. It is the, by the way, the Portuguese who have always taken a head start in terms of even discovery of the ocean currents, etc., Gulf Stream, and so on. Portuguese were the ones who led that. So here, when we talk about the region of Sargasso Sea, it was initially discovered by the Portuguese. When they came upon this area, they came across a zone of absolute calm condition where the water was not moving, and the water was completely riddled with this brownish coverage. What is? The seaweed. So this seaweed in Portuguese, that is termed as sargassum. Sargassum in Portuguese refers to seaweed, and it is from here that the term sargasso was eventually taken. So while this is very good for biodiversity in general, good amount of biodiversity, but a nightmare for navigation. These weeds, they get stuck in the hulls and the propellers of the ships. And oftentimes, not only does it lead to corrosion, in many of the cases, it leads to breakdown and the ships getting deserted in the middle of the ocean without any engine to help them move. So that is where it can become nightmarish a scenario. Now, how is it or why is it that the Sargasso Sea is created? Because when you take a look at the ocean currents, let's suppose you have the North Atlantic current moving like this. Now, as the North Atlantic current moves, water nearby will also be moving slightly. Water nearby will also be moving slightly, but that's it. Similarly, Gulf Stream, water nearby will also be dragged by the Gulf Stream. Somewhere here also, somewhere here, somewhere here. Then west wind drift, North Atlantic drift, somewhere here, somewhere here. Water will be dragged in the nearby vicinity. Then you have the Canary current. But in the central portion, there is no oceanic current to bring any motion here. Plus, to add on to the fact that this central portion coincides with the subtropical high pressure, the Azores high, right? Or the Bermuda high, that the high pressure region, the subtropical high pressure lies here, the region of horse latitude. So that means here you don't have a vertical wind, or a kind of a horizontal wind motion is also not present. So if you don't have a horizontal wind motion which is present, then what will happen? Water will stay where it is. Water will continue to be prevalent in the same place. So as the water is still, the temperature is higher, there is no motion, growth of seaweed. And that is why Sargasso Sea, it is said, is bounded by the North Equatorial Current to the south, Gulf Stream to the west, North Atlantic Drift to the north, and Canary Current to the east. This is said to be in trivia in many of the GK quiz, general knowledge quiz, etc. This question used to be asked earlier, that which is the only sea which is not surrounded by land from only any side. So that is your Sargasso Sea, which is very rich in seaweed or sargassum. Understood? Good. That brings us to the end of this particular module. And next we come to the module of coral reefs. So for corals, no, in the region where you have the Sargasso Sea current, you don't have the trade winds. That is the region of the subtropical high. Okay, the high pressure. The look at the PPT of module 7 about the permanent wind system. You will find the in pressure belts, that is the region where we have represented Bermuda high. Okay. So now we'll come to the portion of coral reefs, and here we'll familiarize ourselves to the concepts that we have to cover. Uh, I'm not sure I have included the portion of the PYQs here. Let me check. I have not included that, but if it is present, we will discuss this for sure. So we have not included that PYQs for today. We'll be discussing those PYQs tomorrow. Okay, that is when we'll be discussing it. Don't worry. So corals are something that you study even for the portion of environment and ecology. There also you cover this about corals and coral reefs in quite sufficient amount of detail. Now, when we talk about coral reefs, from this is, by the way, the area which is relevant for your prelims as well as for your mains. In your prelims, conditions required for the corals. For the corals, okay, and also coral bleaching. These are generally covered under your portion of environment ecology. Coral bleaching. For your mains, formation of atoll, types of or simply coral bleaching. Okay. So here, when we talk about coral reefs, this is what they appear to look like. These are underwater systems. Now, on the face of it, they give you a wide hue of appearances in terms of different coloration pattern: blue, green, orange, pink, violet, velvet, all the different color pattern you will observe. So, immediate ideation is that these are plants. Immediate preconceived notion in the minds of people is that the corals are plants, but they are not. All these, they are made out of individual single animals, that is coral polyp. An individual coral is what is a coral polyp. It is an animal. It is stuck and it sticks itself to the ground surface underwater here. Now, that coral polyp has got tentacles, right? It has got basically the presence of tentacles. This is your coral polyp. Now, this has got the presence of tentacles. Now, basically, if you take a look at the morphology, the system of the corals, it is very simple. Now, because these are fixed to the ground, they work on accumulating any amount of material which is floating nearby. They capture it and they eat it up. But obviously, when you are fixed to the ground, your access to the availability of nutrition is very limited. You don't have that much available nutrient which is floating freely around. So that is why these corals enter into a mutually beneficial relationship, a symbiotic relationship with a group of algae, that is zooxanthellae. And it is that zooxanthellae which provides this vivid coloration pattern to these corals. So the zooxanthellae that gets attached to these tentacles. Zooxanthellae. Now zooxanthellae, they basically have the presence of pigments with which they can carry out photosynthesis. Can carry out photosynthesis. Now, when they carry out photosynthesis, they manufacture enough food, not only for themselves, but also the coral, the host on which they are actually living. So that is where they are able to manufacture or are able to churn out a lot of food in return of it. Okay, so that is something which is observed. Now, this mutually beneficial relationship, zooxanthellae having the various coloration pattern, that gives the different coloration that you see of the coral reefs. Now these reefs, they are held together by a very strong calcium carbonate exoskeleton. So what these corals also specialize in is that they will synthesize calcium ions, they will synthesize carbonate ions from their surroundings, and they will synthesize all of that and they will manufacture calcium carbonate. And with that calcium carbonate, they will be able to build a very strong exoskeleton for themselves. Right? Now, that is where all these corals, they get joined by that calcium carbonate exoskeleton. All of them, they are joined, their calcium carbonate exoskeleton, eventually it patches up and you have a large reef which gets created. So a coral reef is an underwater ecosystem characterized by reef building corals. Reefs are formed of colonies of coral polyps held together by calcium carbonate. Most coral reefs are built from stony corals whose polyps cluster in groups. One of the largest coral reef formation is what you observe in the Great Barrier Reef in northeastern part of Australia. Now, these corals, they are also what are referred to as tropical rainforest of the underwater ecosystem. Because just like the rainforest, these also carry out a lot of photosynthesis, the zooxanthellae at least. So they keep on providing oxygen into the water, which is very much required by the fishes and the other species in water. And secondly, The corals also naturally provide shelter to a wide variety of species, right? They provide shelter to a large variety of fishes, large variety of various species. So that is why they are oftentimes, in a way, having a similarity with the tropical rainforest systems. Okay. Now, these corals, they are divided into various types depending upon the conditions that they grow in. You have the warm water corals, you have the cold water corals also. Not much is known about cold water corals. So these are some of the corals which grow at in the benthic zone as well. So for them, obviously, you don't require the presence of zooxanthellae because sunlight doesn't penetrate into those areas. But you have some cold water corals in the region around Norway, in the region around the Scandinavian countries. There also you have some cold water corals. But majority of the corals across the globe, they are the warm water corals. That is, they grow in warmer waters. And they basically are the ones that have zooxanthellae as the mutually or the symbiotic partner. So these are your warm water corals. Now, warm water corals, basically, they require certain conditions to grow. What are those conditions? So, conditions required. Guys, basically, I hope we are okay if we finish this chapter before ending the session today. This is not a very big chapter in particular. So that tomorrow we will initiate the discussion from Indian geography. So are you guys okay with having another 15 minutes of the session? Or is it something which is out of the window? Another 15 minutes we can take? Okay, perfect. So here, the conditions required for the warm water coral. So all the warm water corals, they will grow in temperature which is ideally around 24 to 25 degrees Celsius. And temperature should be consistent. Consistent temperature around 24 degrees to 25 degrees, or 26 at max. Sudden variation in temperature will lead to bleaching or the death of corals. Because just like the other marine species, corals also will have very less thermal tolerance window. They are not able to tolerate much variation in thermal temperature conditions. So their temperature tolerance window is very, very little, very less. Now, to add on to this fact, you have the consistent temperature, availability of sunshine, of sunlight for the zooxanthellae to carry out photosynthesis. Then clear saline water. What is the meaning of clear here? It should not be muddy. It should not be murky. Because if you have muddy water, turbulent water, sunlight won't be available for the zooxanthellae. So that is why you need clear saline water. These are few of the conditions which are required. Okay. So availability of sunlight will be available in which area? Continental shelf. Sunlight is not available in continental slope. So that is the reason why, hence, these corals grow in shallow waters. That is why where you will find a lot of islands, for example, Caribbean islands, for example, Indonesian islands. There in the island region between multiple islands, the water is not very deep. So that is where you will have a lot of corals. In fact, around one third to one fourth of, or one third or even more amount of corals in the world, they are situated in the region between Indonesia, Philippines, then you have Solomon Islands, Polynesia, Australia, Malaysia. In this entire vicinity itself, you will have significant, almost more than 33 to 35% of the warm water corals of the globe. They are situated or concentrated in that area. Okay. Now, here, how do they grow? So basically, when the corals are in presence, these corals will have the calcium carbonate exoskeleton that they will build around them. But then, after they die, they will leave behind that calcium carbonate exoskeleton. They will leave that. Again, the next generation of coral will grow on top of the older calcium carbonate exoskeleton. And when they will die, they will leave behind that also. Then the next generation will grow on top of that. The lifespan of certain species of corals, by the way, have been found to be present for 5,000 years and more. But not all the corals live such a long life. Many of the corals, basically, they survive for few hundreds of years. So, in many of the cases, what also happens is, let us assume you have this as a sea level, right? Let us assume that these corals, they keep on growing. They keep on growing. A situation will come when they emerge above water. The moment they emerge above water, they will die. Why? Because of the simple phenomena that these are marine species, right? So don't apply the logic that if I can survive above water, then what VIP these corals are, they should also be able to survive above water. At least they are getting oxygen. No, marine species, aquatic species, they cannot survive above water, so they die. So once these corals they die, basically they leave behind a very hardened and stony calcium carbonate exoskeleton. Now, calcium carbonate, I hope you are aware, is whitish in appearance. White, generally very bright white. Now, this calcium carbonate, rocky surface which is created, that gets weathered and pounded by the sea. That is where you have the creation of white sand in many of the places. Now, this creates a kind of an island of sorts. You have birds which migrate over very long distances. Maybe few of these birds, they will drop certain seeds here and there. So as they drop certain seeds here and there, this will lead to the growth of certain plants, isn't it? Certain types of plants will come into existence. Now, as the plants will come into existence, organic matter will also be supplied to these particular areas. That is the ground surface. The ground will get all that organic content as well. You will have very small, few bushes also, which will continue to rise here. Right. Now, eventually, what you observe is the creation, the formation of a kind of a coral island. But this island has been created why and how? Because the corals eventually emerged above water, and that is all that is left of them. You have many islands in Lakshadweep which have been created by this process. You have many islands in Maldives which have been created by this process. That is why, in these particular islands in general, when you will go, you will find white sand beaches to be very prominent. White sand is very prominently and commonly available in these areas. Okay. So this is your global distribution of warm water corals. As you will observe, a very significant majority is present here. This is also the region. This entire region is also what is referred to as the coral triangle. That is what is also known as the coral triangle. Now, and observe this, wherever you have shallower waters, wherever water is not very deep, you will have the presence of coral. So around islands, observe this, Lakshadweep, Maldives, all the way till Diego Garcia, you have a continuous formation of these coral islands, isn't it? So wherever you have these island formations, you will have the presence of corals because you will have shallow water, availability of sunlight. Then sometimes what happens, as the conditions they become adverse, as the conditions they become hostile, maybe the sea surface temperature suddenly rises by 3 degree, 4 degree, maybe there is pollution in the area, maybe some other factor, Whenever the conditions are not conducive enough, the zooxanthellae, their productivity reduces. Now, let's suppose the water has warmed up. There's a marine heat wave, and the temperature of water has increased, has risen up. So, in that area, you will observe that the temperature, as it is rising, the zooxanthellae population will start leaving, they will die. Now, if the conditions are reverted within 30, 35, 45 days or 60 days, the zooxanthellae population can come back and repopulate these corals. But if the conditions continue to remain hostile for a continuity of the period of 35 days, 40 days, 50 days, and so on, that is when the corals, they start dying because they don't get enough food, right? So that is what leads to mortality of the corals. So when the zooxanthellae population leaves these corals, so all the color pigmentation, that is something which goes away. What is left behind is a stony whitish coral in appearance. That process is coral bleaching. Bleaching is something that you use normally as well. Let's suppose any of your whites, when they get dirtied, you give it for bleaching sometimes, such as tablecloth, etc. Why? Because it brings back the whitish appearance. So here also, when we talk about bleaching, so here the zooxanthellae population, when it escapes, that is when you are left behind with the stony whitish coral which is appearing. That is your coral bleaching. Okay. Now, here, when coral polyps lose their symbiotic algae, that is the zooxanthellae, that is coral bleaching. Without it, the living tissues are nearly transparent, stony skeleton can be seen. So, what can lead to coral bleaching? The causes of coral bleaching. Causes. First of all, sudden rise in temperature. In temperature. Then, marine pollution. Marine pollution can be of various different types. Marine pollution can be solid waste dumping. Marine pollution can also be oil spills. Global warming will lead to sudden rise in sea surface temperature. Okay. Muddy water also, yes. Solid waste dumping will include the plastic pollution. Then unsustainable fishing activities. Fishing activities. Such as the bottom trawling. Bottom trawling is a process where you attach a fishing net to the boat, and as the boat moves, the net scratches the sea bottom. So what that means is the purpose is to catch any fish hidden even at the sea bottom. But what it means, all these corals, they are uprooted. So the entire ecosystem of the sea comes down. The further production system, that is hampered, right? Those regions eventually turn out to be dead zones in the long run. India has one of those regions which still indulges in bottom trawling. And that has been one of the point of contention between our fishermen and the Sri Lankan fishermen, where our fishermen, basically, we say that, or we still carry out bottom trawling despite being banned by the central government. We do that. But then that is what the Sri Lankan fishermen, they get angry about, that once you carry out such fishing activities, future fish catches in that area also reduces. So these, then you have diseases, bacterial and fungal. So because of any of these, you will observe that the zooxanthellae, it is the algae is unable to survive. Their productivity initially decreases from 90%, it decreases to 60%. If it decreases beyond 60%, that is when they start leaving the corals in large mass, and you are left behind with a kind of a whitish coral. So this is the impact of bleaching. Okay. Sunscreen destroy coral? As in, if you apply sunscreen on corals, then, or are you talking about sunscreens in general? Sunscreen, many of the cosmetics in general, they consist of oil, they consist of microplastics as well, and that is why they have the ability to create pollution that can destroy corals, but not sunscreen in general. I don't think so. Okay. uh, so what about sudden decrease in temperature? Rarely will you experience sudden decrease in temperature. In marine areas, in water bodies, the temperature is largely held consistent, right? So that is why even when you talk about the marine species, their thermal tolerance level is very less. Tolerance level to withstand the various temperature variation, that is very, very less. Okay. Nonetheless, here, now we come to, we'll cover coral bleaching, or you will cover coral bleaching in detail in when you cover the portion of environment ecology. Now we come over to the three different types of corals based upon where they appear. So initially, how is it a landmass gets created in the ocean in general? Due to volcanic eruption, isn't it? Volcanic eruption, basically, if you have water here, volcanic eruption can lead to creation of a landmass where its height keeps on increasing. It emerges on top of water, right? And then, maybe due to endogenic forces, 5,000 years down the line, 10,000 years down the line, maybe this landmass eventually can sink. That is a natural cycle of upgradation and degradation of landmass. Now, when you have the creation of such a landmass like this, let's suppose an island of sorts, okay, now the corals will initially start growing here on the sides. That is where they will start growing. So these which grow on the fringes, this is what is known as the fringing reef. Then let's suppose after some time, this landmass, due to endogenic forces are also various types. That is diastrophism. There also you have aperogenic, orogenic. So due to endogenic forces, let's suppose this landmass undergoes subsidence. Here is where the water was. Here is where the corals were. And let's suppose the landmass has actually sunk. So now the corals, wherever they were present in that area, the landmass has sunk. So there is a water body in between them. See, observe, this landmass has sunk. So this is the region where the corals, they have basically turned into a kind of an island of sorts, and you have water in between. This is your barrier reef. And eventually, if the entire landmass sinks, leaving only the coral islands behind, that is an atoll. So these are the geographical variations in terms of corals. So fringing reefs, they are found across the coast of the continents or islands. Fringing means on the fringes. Fringes means what? On the sides. So they are formed across the coast of the continents and islands. Their surface is connected with the coast and rises up to a low tide water level as a rugged and uneven platform. This is where the corals will be in existence. Okay. Then, as the central portion, let's suppose, sinks in this area or in any area, that means you will have water which comes in, and you will have a kind of a barrier of sorts of these corals. So these are situated away from the coast, and in between the coast and the reef, there's relatively wide and a deep water lagoon which comes in. So this is your barrier reef. This is what is your barrier reef in general. This is the barrier reef. And let's suppose the central portion completely sinks down. Then you are left with nothing but the islands left behind by the corals. Observe this one. So observe how this is very bright blue. Why it is bright blue? Because here it is the seafloor made out of the corals. And the seafloor made out of corals in this region will be made out of calcium carbonate. Calcium carbonate being whitish in appearance, that is why here you have a greater reflection of solar rays. That is why in these areas of coral reefs, you will find the water to be turquoise blue in appearance. And observe, water here is very dark. Why? Because this is where you will have a kind of a steep gradient in terms of the corals. It is here where the land would have finally submerged, right? So these are the most common type of coral reefs and are roughly circular or horseshoe shaped reefs with a steep outer slope leading to deep water and lagoon in the central portion. So that is how eventually a fringing reef can lead to the formation of an atoll as well. If the conditions are prevalent, if the conditions are conducive, a fringing reef can lead to the formation of an atoll. You will have many such atolls in presence in the region of Maldives, in the region of Andaman also, in the region of Lakshadweep also, in many of the islands in the region of Philippines, Indonesia. You will have many of these atolls in existence. Pacific is filled with many of these atolls. Okay, so these atolls, obviously, so that is why the next time that you observe these turquoise blue images of water anywhere, don't think about it that in our region water is so dirty, there the water is so clean. No, there the water appears in this way because of white base, the calcium carbonate base created by the corals. So this is the entire process of formation where initially a landmass gets created leading to the fringing reefs on the sides. Then eventually after, let's say, thousands of years, due to endogenic forces, the land starts to sink. The reefs, they are left behind in the same place, but as the central portion sinks, water comes in between. You have the creation of a barrier reef. Then again, as the central portion completely sinks, you are left behind with that coral structure that is an atoll. Okay. Now, these corals have significant amount of economic utility, very significant economic utility. First of all, with the immense amount of shelter that they provide, or in a way, they provide natural habitat for a wide variety of fishes. So these corals are very beneficial for the fishery sector, right? So in the areas of the corals, wherever you have corals, a lot of people make their income, make their money from fishing activities. Tourism is another sector that it supports. A lot of people visit these places. Then you also will have the ecological benefit, obviously, in terms of application and supply of oxygen underwater, etc. Many of these corals, they are also being explored for their medicinal properties. Few of them are found to be curing certain ailments. So these are your economic benefits associated, right? So drugs to treat cancer and other diseases, algae, they replenish the amount of dissolved oxygen. And these corals, if you think about it, let's suppose you have the presence of corals like this in any of the area like this. Now, even if there's a large wave which is generated, a kind of a tsunami of sorts, or not tsunami per se, but let's suppose a storm surge during a cyclone which is generated, that will be bunted out by this coral. So coral will act as a buffer zone to protect that area as well. The impact of storms, cyclones, etc., won't be felt in the interior. Okay. So that is all that you need to know for the corals from the portion of geography. So what is it that we have studied in corals very quickly? What are these? Right? These are your animals, coral polyps. Now the coral polyps, they synthesize calcium and carbonate from around them, from the water, and they make up calcium carbonate exoskeleton. So that calcium carbonate exoskeleton, it joins the corals together, forming large reefs, reef building corals. Now, the warm water corals, they are the most predominant ones. They grow closer to the surface where there will be availability of sunlight so that the zooxanthellae population can flourish. They require a consistent water temperature around 24-26 degrees Celsius. They require clear, not muddy, clear saline water. Okay. When they die, they will leave behind the calcium carbonate exoskeleton to be utilized by the next generation. Whenever the zooxanthellae population dies, that leaves the coral as a whitish stony skeletal appearance. That is what is coral bleaching. And these corals are referred to as the tropical rainforest of the underwater ecosystem because they replenish the water ecosystem with oxygen and they provide sufficient amount of shelter and food for the other species in the region. Then furthermore, these particular corals, they are classified geographically into fringing reefs, barrier reefs, and atolls, depending upon where they are to be found. So when we talk about the region, let's suppose immediately at the fringes of the continents, you will have the fringing reefs. Well, let's suppose the land in between the reef or the fringing reef and the land has subsided, water comes in. That is a barrier reef. Then let's suppose the entire landmass has undergone subsidence, leaving the corals behind. That is your atoll. Okay. So this is relevant both for your prelims as well as for your mains examination. Yes. Okay. That is where we'll restrict the session here today. Thank you for being so very patient. We'll meet again tomorrow, where we will continue for the from the portion of India and Indian geography, India's physiographic division. So today, because we have already exceeded the time limit, I would suggest to you whatever questions that you have, kindly keep it reserved for tomorrow. Tomorrow, first half, before the initiation of the class, we will solve those questions. Okay? Yes, Pranay. So that will be all from my side, guys. Thank you for the very patient hearing. See you again tomorrow, where we carry out the all important discussion for the portion of Indian geography. Till that point of time, you guys also relax, take care of yourself. Goodbye. Have a good night. Thank you.